We have the we have the Managing Director, Mr. Mike Turbot from Austpac Resources. As I mentioned, they are fortunate to count two multinationals on their share register, and I'll let Mike tell the story about Austpac. Please welcome Mike to the stage.
Thank you. Which is the... Ladies and gentlemen, thank you for staying to suffer, but I'll try and enliven your afternoon with a completely different story to one that you've been hearing. Austpac may be called resources, but we're really a recycling company, converting steel industry waste into dollars for our shareholders. A normal disclaimer, just an overview. We've developed technologies that are, and patented technologies that are cost effective, energy efficient, they're very green. We even have the ability to capture carbon dioxide. We burn a bit of coal, but we capture the carbon dioxide off that, so we're carbon capture capable. Our technologies, we started working with titanium minerals and developed a process to make synthetic rutile from ilmenite. That led us to part of the process was regenerating the waste acids, and that led us into the steel industry. Steel industry has a lot of waste iron oxide and spent acid, and we can recycle that to produce high purity iron for foundry castings or steel making, and of course strong hydrochloric acid for recycling back to the industry. Our facility will be used as a steel waste recycling plant in Newcastle, the Newcastle Iron Recovery Plant we call it, and the project will commence operations next year. We have no debt, and the plant, to complete the development, is fully funded. At full capacity, the plant will generate about $7 million a year, but more importantly, it's a leading patented technology we can take to the steel industry of the world, and that's a tremendous opportunity for ourselves and our shareholders, of course. Briefly, a corporate summary, very small board. The key to Austpac is John Winter, very innovative chemical engineer. He's been with us for almost, well now I guess 15 years. He's the key to our patents, the innovator. He's a world expert in fluid bed roasting. I won't get into the details of that, but he's a leading light, and he's supported by 11 people at 11 technicians and engineers in Newcastle. Our major shareholders, Steve mentioned, Cronus International is a titanium dioxide pigment producer. That's the white pigment that goes in paint and plastics. In the process of making, making pigment, they produce a waste iron chloride slurry. Cronus recognized the ability to, rather than solidify that and take it in a ship and bury it in a mine in Norway, to actually recycle at their plants in Germany. And so they joined us as our largest shareholder. BHP Billiton, they got involved with us in 2007, 2008. That was in the synthetic rutile phase of manufacture. We started building the plant. And more recently, Orient Zirconic, the largest zircon processor in China, and you know all that zircon we sell up there for the tiles, etc. These guys are the largest, about $1 billion capitalization. They actually, as you'll see later, we actually sold an asset to them, but they got so interested in the company, they said, well, gee, we better buy into this. We were trading at 3 cents. They took the placement at 6. So certainly some interest in the company itself. I won't go into the details of the company. We're still a penny dreadful, but we say the only way is up. We've got sufficient cash, and certainly we'll finish our project. What does the project look like? Steel industry. Well, most of us know, we've seen these sort of pictures before. Sparks flying everywhere, a molten steel. It's oxidizing, becomes iron oxide, and basically we can use that as one of our feedstocks. Steel industry waste, looking at where we're at, a molten steel would go from a melter, would potentially go to a rolling mill to be rolled into railway lines, or more probably into coil or sheet. that coil or sheet, if it's going to be the waste from the rolling mills, of course, is mill scale, and it comes to, we can recycle that, comes to Austpac. The coil or sheet from the rolling mill, raw steel or the raw sheet, if you're going to coat it or galvanise it, it needs to be clean. The surface will need to be absolutely clean because to get the oil off. So what they use is an acid bath. And it's a process called pickling, steel pickling. You're using hydrochloric acid to clean off all the oxide. The clean steel, pickled steel, goes off to be processed, and ultimately that acid bath gets depleted, and we can take its product and separate the iron chloride from the iron chloride into iron oxide and to iron. So that's our raw materials. The two at the end, spent pickle liquor and mill scale. What do we do with it? We start the process with, it's a fluid bed process, 3 separate fluid beds. First step is take that mill scale and pickle liquor and then put it in a vessel that roasting at low temperature, maybe 150 degrees, drives off all the water in the pickle liquor, and we end up with solid iron chloride pellets. The pellets then go forward to the next phase, which is high temperature roasting, and that breaks down the iron chloride into the fluid bed that's called the fluid bed pyrohydrolysis roaster. It doesn't matter about the term, but the high temperature roaster breaks down the iron chloride into hydrochloric acid, which we can sell, and iron oxide pellets. The iron oxide pellets don't really have a value, and this is where one of our patents is coming in with John. I nagged John Winter, and he finally said, Mike, come up and look at what we've done. And he's invented a new process to reduce iron oxide to iron metal. We call it metallization. I mean, that's really a significant term, isn't it? The gases from the metallizer are recycled to the fluid bed evaporator, and of course, the product is iron chips. We're the only process in the world that can take iron chloride and break it into 2 saleable products. Other acid regeneration processes end up with generally an unsaleable iron oxide and weak acid. So that's what we do with the technology. Well, what are we doing? We're in Newcastle. It's the Hunter River, Newcastle City behind, or the city's in this way. This is the Rio Tinto coal loaders. BHP's now built a coal loader here. It's Australia's largest coal export port. We're we're tucked away right behind everything in an industrial site. There's a coke works, trucking business, and this is our little plant here. Very compact site. This is what the plant will look like. It'll actually look a lot better than that. Mill scale is delivered to a bulk storage shed, taken with a front end loader into the preparation area, raised into the evaporation vessel. The pickle liquor delivered in tankers to the tank farm into the evaporator. The products, ultimately from there, at the end, the regenerated acid back to the tank farm into tankers and sold. The iron chips go to silos here, where they either can be directly sold or sent to a briquetter, which is underneath this building, and iron briquettes are loaded out by truck. So start with mill scale, little chips of iron oxide. The process makes them into pure iron, which is a saleable product for specialist foundry castings, etc. But if you're going to use it for feeding an arc furnace, an electric arc to make steel, then it needs to be much more solid and much heavier. And we have installed a Coppern briquetting roll, and it produces something like about twice as large as your barbecue briquettes, but about 10 times as heavy. And that can be loaded into an arc furnace and go through the slag layer, because it's so pure, it's made from only iron oxide, and the iron that we take out of the acid, That is a great material to adjust and melt. As you can imagine, you put a car body into an electric arc furnace, there's a lot of other metals in there. Ultimately, they get contaminated. This is a good correction material. You can use that or chopped up ships, I guess. They're the two potential things. The plant capacity, full capacity as designed, we have capacity to take 17,000 tonnes per year. It's at Newcastle. We'll produce 18,000 tonnes of briquettes or iron chips. You say, well, how's that, you alchemist Turbot? Because how can you make iron oxide into more iron? Quite simply, because we're taking a lot of pickle liquor and we're making 18,000 tonnes of acid, and all the iron that's in the acid ends up in those iron chips or iron briquettes. So there's no effluent liquid or solid effluents from our plant. It all goes into product. We've got that site that site's leased for 25 years. We've got longevity. We have supply and sales agreements with CMC Co-Metals, a large steel producer, steel metal trader. They're based CMC Co-Metals Australia is and they're going to supply them for the initial production of the plant. They're going to be supplying the mill scale and the coal, and they'll purchase the iron chips. On the other hand, the pickle liquor is going to be supplied by Orica, and they're going to purchase the regenerated acid. So first phase for Austpac, when we're starting up commissioning, first probably 6 months of operation, we'll end up with we're fixed for all our raw materials. And as I said, that operation, that plant, fully funded, company has no debt. What have we spent to date and where are we with funding? As I said, BHP Billiton bought into the company. We used the money to construct a demonstration plant for Cinrutal. The acid regeneration part of that didn't work so well because we'd built it in a hurry. We learned from that and we said, well, what do we do with this plant now? The idea was then to turn it into a small commercial operation to recycle steel waste, and that's what we're about. In 2011, Kronos, the pigment producer, recognised the potential to treat his waste, or their waste, and they have agreed to inject 12.5 million to reconstruct the plant, and that's through way of a licence, capital investment in Austpac and licence to use the technology at their plants. Orient Zirconic got interested in the technology when they came and approached us about acquiring an asset we had, and decided to invest at, share price then was 3 cents, they invested at 6 cents. The chairman was very excited about potential in China, and we have a loose arrangement where once the plant in Newcastle's running, they will potentially look at working or looking for opportunities in China. No other obligation. As you can imagine, China's a pretty big market. The other string to Orient Zirconic was they bought an exploration licence in Victoria near Horsham. That's the old WIM 150 deposit. We own 100% of that. We're tied up with a company called Australian Zircon, who are spending to complete a bankable feasibility study. It really has no strategic value for Austpac because we can't process the minerals there. It's primarily a zircon deposit. Orient Zirconic want the product. So they were willing to pay the 7.5. Of course, what that means, the funds are now in a trust account and pending approval of the transfer of the licence by the government. And that means we're pretty well off for a change. So, this company, you might have noticed on the slide, this company's been going since it's been listed since 1980, pardon? 86, so it was probably listed in 1986. You don't survive that long without eating on shareholders' funds, so we've got a lot of capital out at the moment. Long and short, the capex for the plant we have is 18 million. We spent 12 to date. The balance is covered by that sale of the WIM 150 heavy mineral deposit. Timelines: construction will continue through the first half of next year. Commissioning will start toward the end of that with sections of the plant, commissioning sections of the plant in the end of the first half. Will be operation revenue commencing in the second half of 2013. Obviously, there's a settling down period. And by 2014, we should be at full capacity and making a profit of about $7 million a year. However, that's not the key. The key that is great because it'll be the first cash flow, this serious cash flow this company's ever had in its life, long life. What the potential is, of course, is it'll be a reference site for the world steel industry to handle their garbage, to handle their waste. The plant will demonstrate the process, and it'll lead to licenses in the steel mills. Future revenue streams from recycling mill scale and pickle liquor and other mixed oxide dusts. We've already got interest shown from various sources. One steelmaker in the US has expressed a strong interest in replacing a derelict acid regeneration plant. They're coming to look at the plant next year when it's operating with a view to license. Recovering iron, another steelmaker is looking at recovering iron from a contaminated, zinc-contaminated fine oxide waste dump. And that will lead to potentially 2 licenses, generate cash flow, licenses, of course, with other steel mills, and potential to develop with engineering groups, cooperative ventures to build specific plants. Perhaps we supply the technology, they supply the funds, and we'll jointly own it. Looking at, say, the potential in North America, each of those red dots is a steel mill, potential for our plant. One of them has already shown an interest, and we're not even operating. The rest of the world, well, how many of these licenses might we sell? We don't know yet, but the only way, I think, is a profitable way and up. So there's many opportunities to generate, will be many opportunities. Just on the very briefly, we started with synthetic rutile. If you're interested in this, go to our website, but we make the highest grade feedstock for making titanium metal. It commands a premium on the materials, say, Iluka produced, the synthetic rutile. We're going to use the existing leach section to make bulk samples, work with titanium sponge producers to look at the potential for synrutile, and we perhaps in 2014 look at that again. But the main focus of Austpac is iron, recovering it, recycling it, the garbage dump for being the garbage processing unit for the steel mills of the world. And thank you very much.